All right,
Yes.
sorry for the delay, everybody. Again, my name is Don Fick, and I'm with the Library Telescope program, and we're excited to once again start our monthly programs where we're talking about the Library Telescope and how you could use it, and about our program and how it works in the libraries, those type of things. And so we've been working as a task force for the last couple of years trying to grow the program and share best practices. We have multiple countries and several clubs involved. So it's really been very exciting. Tonight's program we're going to have it's about the most fascinating events in 2022 as seen through the Library Telescope. And we're glad to have John Goss from the Astronomical League presenting. I did mention that we have quite a few countries involved. We've been expanding, or actually tracking where it's expanding internationally. And if you go to the librarytelescope.org, you'll see a map that looks a little bit like this. You can click on a country, for example, the US or Canada or the Netherlands or the UK, and find where there are locations of libraries, telescopes. And so it'll give actually specific libraries, for example, in a particular state. You can just click it and it'll give you the list of what we know about it. And I'm sure there's more than we even know about, but there's quite a few locations throughout US and Canada, and in some in Europe. And this is a list of some of the programs we've done in the past. So tonight's program, we will record this and we'll put it out to our YouTube library. You can see it down the bottom. If you see the librarytelescope.org, just go to that website. And at the very top right of the website, you'll see a YouTube button. You can click that. You can go and see not only what we've had for 2021, but we've actually been doing this back for over a year now. And so tonight's program, of course, is the most fascinating events. Next month, on February 16th, we'll have what's called binocular viewing in the winter skies. This is a really great time to look at binoculars. And so I'm very excited, John, to have you tonight. This is a really terrific year for those in the pandemic, just looking for something to do. There's some really great objects. So I'm going to stop sharing. And if I can get you to share, then you can, we'll pick up and get you going on your program here. So I'm very excited about this. And by the way, behind the scenes is Tom Lynch. He's one of our task force members. He manages our Facebook page. If you see good questions being answered by someone, it's probably Tom. He does a terrific job. And I'll turn over to you, John, and let's go for it. Let me get you going.
Oh, great. Thank you, Don. And you were quite right about 2022 having a number of really good celestial sights that can be viewed through the Library Telescope. But in a sense, 2022 is not like, it's like every other year. There's always something to see in the sky. So I'd like to talk a little bit first about what can be seen typically in our skies, and then I'll move on to the specific ones for 2022. First, though, I want to give a brief description of this wonderful program. It's a program in which there's really no real reason why a library can't do this. It's pretty easy stuff. You have a telescope. We have a specific one in mind, a small portable telescope, but large enough to see interesting objects in. It has quality optics. It's an 4.5-inch Orion star glass, if that makes any difference. Anyway, the idea is that the public library patrons can check it out just as they do books. They take it home, they strap it in their car and drive it home, set it up on a table in the backyard or front yard or wherever. It has a nice finder scope on it, which makes it fairly easy to find interesting objects in the sky, such as in this case, the moon. And we have a zoom eyepiece on it, which allows you to go from a low power to a high power really quickly, really easily. And that's really all there is to it. It's a really fun program for the patrons. It's a win-win for the patrons, for the library, for the astronomy club that helps out with this, to the general public at large. But anyway, let's talk about a little bit about what the Library Telescope can see any year, not just 2022, but any year. So you can go out soon and see some of this stuff. For instance, you have craters on the moon. Okay, but that's pretty cool, because this is not a cheap little telescope. You can actually see some stuff, and if you know what you're looking at, you can try to get a greater understanding of these objects, such as the moon. We have a crescent moon right here, and you can see there are a lot of craters. And I just want to focus on this line right here. It's called the Altai Scarp, which is a wall of debris that was kicked up when an asteroid smacked into the moon 4 billion years ago. Smacked in right there. and shoved up a lot of debris against on the surface and formed a wall around it, which is what this is. And if you look closely, you can kind of see an outline more of this wall going like that. That is something to understand about the moon. The library telescope can easily show it. I think that's pretty impressive for this little instrument. Another item that the library telescope can show, when Jupiter is visible, you can see the planet itself. And in this picture, which I took, I admit I'm not an astrophotographer, but still you can see what I'm talking about. The planet Jupiter right in there. And there are 3 moons. There's 3 little star-like objects off to its side. Well, those aren't stars, those are 3 of its 4 large moons. There's a 4th moon, but in this case, it was hidden behind the planet, so you couldn't have seen it. Another typical object, well, tonight or tomorrow night, or over the next couple of months, you go out in the early evening, you can see the Pleiades star cluster. This is what you might see in the sky without the telescope, and you can see there are a number of stars here. It's also called the Seven Sisters. Even though most people can only see 6 stars, it's still called the Seven Sisters. But through the library telescope, you can see upwards of 80 stars instead of those original 6, 4 there, 5, 6. You can see up to 80. This is a pretty good thing to see through a little telescope like this. It really works. I think that probably the most incredible object that you can see with this telescope is the Andromeda Galaxy. Now, a galaxy has a lot of stars, and it has like 400 billion stars. You can't see any of the individual stars, but the blur, the smeared out blur of its combined light, you can sure see that. And the reason why you can't see the stars is because it's 2.6 million light years away. So this little telescope can show something that's well over 2 million light years away. The light that you see, well, on this sketch I made, left that galaxy over 2 million years ago. Isn't that incredible? The library telescope can pick that up. Another object here, we have something called a globular star cluster, which is a cluster of stars, and in this case, it's called M13. And in this case, it's about 500,000, perhaps even more stars, kind of squished together in a ball that's about 160 light years wide. And in this case, the cluster is about 22,000 light years distant. So the light that you see here left that cluster 22,000 years ago. You know, light moves pretty fast, so that's pretty far away. But the library telescope can pick it up. I think this might be my last typical object here, but I really want to go over this because I drew this a few years ago of the so-called, of the Orion Nebula, which is easily seen this time of the year in the south. The library telescope, as I mentioned earlier, it has a 20 power for a low power and a 20 power for its high magnification. So on the drawing on the right, you can see that the nebula, of course, and you see a star right here. And if you zoom in on it, put it up to 60 power, you can see that it's not 1 star, but it's 4 stars. Astronomers call this the trapezium because there's 4 of them, and they are relatively young. They're probably, I don't know, 1 million years old since they were first born, but they were formed inside the nebula here. The library telescope can pick that up. It's a small instrument, but it can still see this stuff. I think that's pretty amazing. So let's take a look at what's coming up in 2022. This year there's quite a few events coming up, but I picked out 5, and we'll be taking a look at those in just a second. But the library telescope is able to see this stuff. Your patrons can check them out, look at this stuff, return the telescope to the library, and they're in for a few treats. Number 1. Let's get into this. Venus. Now, Venus is in the morning sky right now. So if you get up an hour or so, get outside an hour or so before the sun rises, you'll be able to see it in the east-southeast. That's pretty neat by itself. But if you look at it through the telescope, the Library Telescope, you will see that Venus is in the shape of a thin crescent. You know, kind of, you've seen the moon be a thin crescent. Well, that's how Venus will look right now. It look like a really, really small moon. But you see this and you realize, oh, this is another planet that's roughly 35 million miles away, something like that. And it's in our solar system, and it's an Earth-sized world. So the more you read about Venus, you can actually picture it in your mind now on what it looks like through a telescope. Again, this is a small telescope with quality optics can show something like this. So go out, if you have one checked out, go out over the next few mornings if the weather's conducive. Either in January or February or even in March, you'll still see something like this. But Venus is the brightest object in the sky next to the sun and moon. So it's the brightest object in the sky in the east-southeast before sunrise. Now the next object, or the next event, it takes place over a few days, well, 2 days when it's really close. April 4th and 5th in the morning, again, about 60 minutes before sunrise, you will have Venus, of course, very, very bright. But to Venus's right and up a little bit, you'll see Mars and Saturn. You know, Mars is the red planet. And once you identify it, you'll realize why it's called the red planet, because it really is red or orangish red. The idea, though, here is that Saturn, because our Earth is going around the sun, Mars is going around the sun, and so is Saturn. Our positions change so that they appear to shift in the night sky. So in the morning of April 4th, of Mars next to Saturn, and then the next morning, Saturn will appear to have moved to the other side of Mars. Look at this a little bit closer. This is a drawing. This is my representation of what it's going to look like. Now, it's not going to be a blue background. It's going to be a black background, but I had to have something there to make this evident. On one side of the eyepiece, you'll be able to see Saturn, which is obvious which one there is Saturn. And just to the lower left of Saturn, you'll be able to see a dim star-like object, that's no star. That's its large moon Titan, which is the second largest moon in the solar system, easily seen through the Library Telescope. On the other side of the field of view will be Mars. Now notice the actual relative size of these things. The planets are pretty small, even at a fairly high power. So Mars will be red. You might be able to discern some surface markings on it, but I don't think so, at least not until next fall. We'll talk about that in a moment here. So this is on April 4th. Following morning, April 5th, now Mars and Saturn have changed places a little bit. Saturn has moved above Mars. Saturn has traveled like so above Mars. So the next morning, it's right about there. This is seen in one field of view of the high power that you can see with the Library Telescope. This is a very instructive in a way, because you can see the relative sizes of these planets, knowing that Mars is, I guess in this case, it's probably about 100 million miles away, while Saturn is 10 times that distance. You know, it's pretty interesting, wild stuff that you're doing with this telescope. It's a small telescope, very portable, but it's a pretty good quality. It's not a kid's telescope. It's a real instrument that you can see this stuff with. Now, evidently April is going to be a big month for all this stuff. I was just talking about April 4th and 5th. Let's jump now to the end of April, the last week or so, looking again in the southeast, and in the morning, you will notice Venus, as I've been mentioning earlier. It will be the bright object. Well, there'll be another bright object, not as bright as Venus, though, but there'll be another one, Jupiter. So the last few mornings of April, Venus and Jupiter meet up, much like Mars and Saturn did at the first part of the month. You might remember last year, there was a big hullabaloo about Saturn and Jupiter meeting up in the night sky in December of 2020. And astronomers gave it a name, the Great Conjunction. Well, this is very similar. In fact, I think this is an even greater conjunction because Venus is so much brighter than Jupiter and Saturn were back then. And you have Jupiter, the second brightest planet, right there with it. I think that'll be really cool to see. So what are you going to see? Well, on April 30th, the morning of April 30th, you'll have Jupiter, the dimmer of the two, on one side of Venus. And then the following morning, you will have it on the other side. You will also be able to see Mars and Saturn in that part of the sky, but you won't be able to see it in the same eyepiece field of the Library Telescope. So in the eyepiece field on April 30th and May 1st, this is a little bit closer view now. If you have a pair of binoculars, this is kind of how it's gonna look then. The angular distance between Venus and Jupiter is kind of hard to picture in your mind, but you all know how big or how small the full moon appears in the sky. Well, on April 30th, Jupiter will be about that width distance from Venus. And the next morning on the 1st, it'll be on the other side of Venus, again at about the same angular diameter, same angular distance that the moon is wide in our sky. So that's pretty impressive. So this is, again, my artist's representation of what it's really going to look like. April 30th. Interesting thing. I'll point out Venus first. You might recall that I was just talking about Venus being a thin crescent tomorrow morning or over the next few weeks. Well, on April 30th, it will still be a crescent phase, but not a thin crescent. It's more like a halfway phase, but you can still see it. Now look at Jupiter. Jupiter has 4 large moons. On April 30th, you'll be able to see all 4 of them, maybe. If you see it, if you get up early enough and start viewing early enough, you will see the 4 moons, Callisto, Io, Europa, and Ganymede. But Europa is right hugging the edge of Jupiter. If you wait 15 minutes later, Europa will be gone. It's still there, but it will have orbited a little bit more around Jupiter, so it's hiding behind the planet. That's pretty amazing that this little telescope can see these things. April 30th. The next morning, Jupiter and Venus will have switched places. Venus is still a crescent. However, now you'll be able to easily see all 4 of Jupiter's large moons. Europa, which was right here the morning before, has now orbited all the way around to that side. And Io, which was right here the morning before, has now swung around and gone to the other side. Throughout the year, whenever Jupiter is visible, you can watch these moons. The Library Telescope will be able to do that easily, either at its low power or its high power. You can see them both ways. So this is on May 1st. I think that's pretty amazing. Jupiter would be about, I don't have the figure right here, but it's be about 400 million miles away. That's pretty cool. 2022 has 2 total lunar eclipses. I think one's a little bit better than the other, and the one that is really good, I think, is the one on May 15th, because it doesn't happen too late at night. 10:28 is when the totality starts, and then it goes into the early the next morning. But this scope can easily see this. Essentially, what you want to do is point the telescope at the moon, and you'll be able to follow it as it slides into the Earth's shadow. As the moon orbits the Earth, it'll go into the shadow caused by the Earth blocking sunlight. And as the moon goes into eclipse, more and more of it goes into the shadow and becomes dark. But finally, during the total phase, this picture really doesn't do it justice, because during the totality, the moon will not be bright. It'll be a really dark, dull, dim red ball in the sky. It won't be your glowing silvery beacon that it was a couple hours before, because as you know, the full moon is really bright. nice, big, round, and bright. Eclipses can only happen at the full moon. So as the moon slides into that shadow, that big, bright orb gets darker and darker and darker until, well, you can still see it, but it's going to be difficult to see. And it'll be a kind of a red color, which the telescope will pick this up pretty well, but it'll be a red color, and that's simply because of the light being refracted around Earth's atmosphere before it heads off to the moon and causing it to be red. It's like our sunsets are red. So that's on May 15th. That is pretty cool. On November 8th, we have another one, but you have to get up really early in the morning to see this one. This is at 4 a.m. Eastern time. So West Coast people will be favored for this event more than the Midwest and East Coast people. But still, it'd be a very similar type of event with the big full moon sliding into the Earth's shadow, getting darker and darker and darker, turning red, and then it'll start coming back out. It takes a few hours, a couple hours to do all this. So look at that. So what do we have? We have Jupiter, Mars, and Saturn in the morning sky, and then they switch places. And then we have Jupiter and Venus in the morning sky switching places. Now we have 2 total lunar eclipses. One more event, which I'd like to highlight here, which, in my opinion, it might be the neatest one of the year. Oh, excuse me. This is more of the moon and the Earth's shadow during the eclipse. May 15th, you can see it starts going into the shadow. Gets in mid eclipse is about 12:11, then it pops out at about 1:55. And similar thing with the November eclipse. One unusual thing about the November eclipse, though, is that the planet Uranus will be just to the upper left of the moon. The Library telescope isn't going to do this justice at all. It doesn't handle Uranus very well, but it'll sure pick up that eclipse. That is something that you're going to want to see. Now, the next one that I was just referring to that at least for me, I'm looking forward to. It's on the evening of December 7th, the full moon. So this is about a month after that last eclipse. The full moon passes right in front of Mars. Mars will be at its brightest. It will be its brightest that it's been in a year and a half or two years. So it'll be easily seen in the sky. But what makes this interesting is that depending on where you are in the United States, you can see, given the weather, you can see the moon slowly slide in front of this very tiny disk of Mars, blocking it. This is called an occultation. Happens on December 7th. Again, here is a representation that I have from where I live on the East Coast. This is what I expect to see. On the East Coast and the southeastern part of the United States won't be able to see the moon actually move over Mars, but the moon will move above Mars. Now, for the rest of the country, I'll come back to this in a moment. Should have flipped them around. But for the rest of the country, they will see an occultation. This dashed line kind of marks the dividing line. If you're on the southeastern side of this line, the moon passes above Mars fairly closely, but it's a miss. However, if you're on the northeast or northwest side of this line, the moon passes over Mars, passes in front of Mars is how I should put it. So that means that it takes a few minutes for the moon to actually, in its orbit, slide across the planet Mars, and you'll be able to see this event in the Library telescope. I think that's pretty amazing. It's something I haven't seen this type of event too many times in my life, but I want to see this one again. Okay, the reason why I have this graphic in there is to show you some of the respective apparent sizes of planets. You all know about the full moon, about how big the full moon is in the sky, and you can easily seen. Well, the reason why Mars, you can't see it, you can't see a disk with the unaided eye, is because Mars is so small. Apparent, because instead of being 240,000 miles away, which is what our moon is, Mars would be many tens of millions of miles away. So of course, it's going to be a lot smaller in the sky. So is Jupiter, and so is Venus and Saturn and Mercury and so on this graph. So you get the idea that one reason why you need a telescope, such as a library telescope, is for enlarging these small objects so you can actually see a disk. In our case, we're going to be looking at the crescent Venus here tomorrow or so on. Later on this year, we'll be able to see the disk of Mars, be able to see the rings of Saturn, and Jupiter with 4 of its bright moons, bright in quotes. They're bright enough to see, of course. So that's something pretty unusual, I think. There's our graphic back for the United States and the occultation. So what do we have coming up this year? There are a lot more things to see in the sky besides just this. Remember, I started out by talking about how you can take the telescope out and look at the Pleiades star cluster. There are many other star clusters too. That's the one I chose. You can see the Andromeda Galaxy with its 2.6 million light years distance. That's simply amazing. I always find that very astounding. And of course, there are various planets throughout there that you can see. Jupiter and its moon, Saturn and its rings, our own moon with its different craters, trying to understand what all this is all about. So 2022, go ahead and mark your calendars. Number 1, just a review here of what we just talked about. There'll be a close pairing of Mars and Saturn on April 4th and again on April 5th. The mornings before and after these 2 dates, the planets will be close together, but these 2 days, they'll be the closest. 30th and May 1st, another close pairing between brilliant Venus, easily seen Venus, and bright Jupiter. Again, the following morning, they will have switched places, essentially, in the sky. And in the mornings before and after, they will still be very, very, very close. But this is something to get up and see, because you don't witness this very often, of having brilliant Venus and bright Jupiter so close together in the sky. May 15th, going into the night of the 16th, or morning of the 16th, we have a total lunar eclipse, as we just talked about. November 8th, which would be the early morning hours, another total lunar eclipse that is better seen for people on the West Coast, for Mountain Standard Time, Pacific Standard Time, versus the Eastern Standard and Central Standard Time people, simply because it's so late in the morning, or in the dark hours of the morning. December 7th, the full moon and bright Mars. That is something, as I've been saying, that's something I really want. I want to see it. I want to see it. So be sure to mark your calendars for these dates. And let's have one final slide here for you. Because you're watching this program, you probably already know about the librarytelescope.org website, but we are also on Facebook at the Library Telescope site on there. So go to these 2 sites and look it over pretty carefully, because there's a wealth of information. There are graphs, there are charts, there are star charts, there are planet charts, there are ideas on how to use the telescope, guides on to make it much easier to use. Go ahead and check all this stuff out. It'll really help you. And anybody else you know about it, it'll help them use the telescope and get the full maximum benefit from it. So remember that all the telescope is you check it out like a book, you take it home, you set it up, and you start looking. We have a lot of information that shows you how to find some of this stuff. So it's a great program. It's a great program. And I always think that the best thing about it is that, when you're done with the telescope, you can always take it back to the library. And if you like telescopes, you can go out and buy your own, get a bigger one, get a better one. But I'm not putting down a library telescope, because it may be small, but it's powerful. Its optics are good. Its mount is good. It's a great experience. It's a great experience. So with that, I will stop my share. And if you have any questions or comments, perhaps we can field some. I'm not quite sure how you'd all like to do this right now.
Yeah, John, we got actually several questions. Tom, do you have some or something? you were starting to say?
Yeah, I had one question was, what kind of a camera and setup did you have to take those pictures that you showed? Oh, you did it through your cell phone, really?
This is an iPhone 6.
Wow.
And this is the sore subject right now because I want an iPhone 12 or 13, but this is like 8 years ago now. So very, very basic stuff. You know, I think most people will have something similar to this or even better. Or you can use a point and shoot camera by holding it up to the eyepiece. So yeah, it really works. The moon is really easy to take a picture of. The hard part about the moon is holding this up steady and getting the lens of the camera right over the eyepiece. But once you do that, the moon's bright enough to take a regular picture. You know, it's the same distance from the sun that we are, so it's like a normal daytime exposure to capture stuff on the moon. So I probably said too much with that answer.
Yeah, those are pretty good pictures for doing it that way. I've seen people try to take pictures, you know, they can hold the camera in the hand and it's steady and autofocus is a problem. But I've also seen there's, I don't know the name of it, but there's a setup that it goes around the eyepiece and it's got a little like ledge to put the camera on.
Yeah.
And that would, like something like that would work too. But
yeah, a lot of the major retailers have that type stuff, and the prices range from $20 to $60, depending on all the doodads you want on it. Right. And remember, when you take a picture with your phone or whatever, I only show you the best pictures. I don't show you all the pictures. You know, I can take 10 of them, and one of them is going to be good. So
yeah. There was another question. Can you see the great red spot of Jupiter with this? Now, I have not been able to see it from where I am. I'm right outside of New York City.
You might, on my drawings and my photographs, you notice how small Jupiter really is, and that's at the high power for this this telescope. I don't think you can. If you get into the hobby, you'd have to have a higher magnification to see that. It is possible to see it with an amateur telescope, but with this unit, the way we have it set up,
you should be able to see the cloud bands, though.
Oh yeah, you'll be able to see a little stripe.
I've seen that too.
The planet itself, and you'll notice that Jupiter isn't really round; it's flattened because of its rotational, the centrifugal force throwing out its atmosphere, making it more of a smallish oval. But
yeah, and contrary to popular opinion, sometimes actually having it not magnified as much means you can see more because it will spread the light out a little bit less. You can get a little bit crisper view of the cloud patterns and things like that.
Crisper and brighter.
Yeah, crisper and brighter. Let's see here. Someone asked if you had taken a picture of the moon with was that taken through your particular camera there?
Yeah. It was this camera here.
Okay, good. I actually had the 6S, this iPhone 6S, and I think it's actually easier to use than the new one. I've got the 13.
Oh, really?
Yeah, because what happens is there's so many cameras on the other one that it's simply simpler to get that one lined up and find the moon. And you can take some really fantastic pictures with that in a very short time. Okay, so what other questions do we have here? Would you be able to see the asteroid that is near Earth now with the library telescope?
I don't think the question is being able to see it. I think the question is being able to find it. It's dim and it's moving very, very fast. So I will say no. If you were somehow incredibly lucky just to happen to find it, you might be able to see it as a very dim star-like object drifting across the field of view. But that's complete luck. I wouldn't even attempt it.
Yeah, I think you'd have to be pretty lucky at it. I think what you can do, though, and you mentioned a little bit of this, but you can see double stars really nicely with this telescope, and you can see planets, which are really terrific. You might explain the word ecliptic that I noticed in your drawings. What does the word ecliptic mean? Because that does help people find the planets, right?
Right. Essentially, the way our solar system is laid out is that the planets, of course, as you know, they orbit the sun, but they do so pretty much in the same plane. So from our viewpoint on Earth, the ecliptic is the path, the apparent path that the sun takes across the sky all year. And it moves in front of the same stars, the same constellations on the same dates every year, because the Earth is orbiting the sun. Sorry, I almost said the sun is orbiting the Earth. The Earth is orbiting the sun. And so do the planets. So all the planets line up someplace along the ecliptic, which is why you saw that Venus and Jupiter and Mars and Saturn were all kind of in a line. That's the plane of the solar system. A few months from now, they will have all moved in different directions, but they will all still be very close to that ecliptic line. That's all it really is.
Awesome. Thanks. Well, I think we're going to wrap up. It's like we got all the questions taken care of. John, you did a great job. And Tom, thank you so much for the help. This is really interesting. We've got a lot of events coming up this year and all within reach of the Library Telescope. What I love about it, which is something I keep learning more and more about, is really a time machine. You're looking back in time, and that's so cool to think about it. You can date like, oh, this event not even happened, maybe Columbus hadn't even got it to the U.S., to the Americas by that time, and it's well beyond. It's like, wow, this is really amazing kinds of stuff. So
2.6 million years ago.
yeah. So that's quite a long time ago. So we will be putting this video out on our YouTube account. So if you go to librarytelescope.org tomorrow afternoon, you can take a look at it again. Of course, it'll be on Facebook because we recorded it as well tonight there. And what I would hope you do is join us next month on February 16th. We have a terrific program on binocular viewing of winter skies. Not only do a lot of libraries have telescopes, but a lot of them have binoculars, and that's a very logical. Binoculars are not only good at obviously looking for night sky, but for daytime objects as well. But binoculars, believe it or not, you can see some things with binoculars that you can't see with telescopes, because you get a wide range of the field of view, and you can actually see more, maybe a wider field, whereas the library telescope, you can see a few specific stars, but it'll open it up. So it's really like Pleiades. It's amazing in a binoculars. If you really look at that, it's really cool. So John, thank you once again for joining us, and Tom, thanks for the help. And thank you all for joining us tonight. And please pass the word around to your friends about our next month's program, and check out librarytelescope.org and our Facebook page at facebook.com/librarytelescope. Thanks again. Have a good night.